All right, today we're going to be working on lesson 755, and this is where we're going to look more into subtraction with both positives and negatives. And here on the first slide, they're asking us to come up with equivalent, right? So that means equal. So equivalent equations. And remember, equations are just word problems or expressions that have an equal sign with them. So here's what we're going to do. We're going to look at this very first example. And this first example is showing us problems that actually showed this particular bar model. And here's what I mean by that. 2 plus 3 is 5. This is a problem that we should all know, right? And we know that if you take a 2 and a 3 and you add them together, the total, right? So this whole bar is equal to 5. All right. Also, 2 plus 3 is 5, but it's also the same thing as just taking this 3, adding it to 2, and that also is 5. So what I'd like to do is I made the other bar models to show these two problems here, right? So the first one, or the second column, is 9 plus negative 1 is 8. So I did that here to show that, right? If we have a positive 9 and a negative 1 and we add them together, we end up getting 8, right? That's the total amount. That's what this whole bar is worth, okay? Same thing over here. Even if we don't know what the other number is, if we have negative 11 and we add it to whatever x is, we get positive 7. So we're going to be using these bar models to fill in these columns here. So let's take a look. The second column is saying, now we have to follow these examples exactly, right? So if 2 plus 3 is 5, we also know 3 plus 2 is 5. And all they did was switch they're called addends, right? The things that we're adding up to get the sum. So if 9 plus negative 1 is 8, we also know that negative 1 plus 9 is 8. So that's what they're asking us to fill in here. So negative 1 plus 9 equals 8. Okay? And we know that that's true, right? Because if we had 9 puffs of air in a hot air balloon, we'd go up to 9. And then if we added 1 sandbag, we would go down to 8. So 9 plus negative 1 is 8, or negative 1 plus 9 is 8. And we can do the same thing over here, right? If 3 plus 2 is 5, that's the same thing as doing x plus negative 11 is 7. So that's what goes in here, right? We're just flipping those addends. So x, x plus negative 11 equals 7. Okay, so let's go to this next one. And the next one is actually showing that, addition is related to subtraction. So, and looking at our example, if we had 5 and 3 on our bar model, how would we solve for this block here, right? Well, we know that if we start with a total of 5, if we were to get rid of this amount, 3, we'd be left with this amount of 2, right? So we have to model a problem just like this for this row here. So that means they're telling us that if we know 8, if we don't have this 9 here, how would we find out what that 9 is? Well, if we take 8 and we get rid of this amount, we're going to be left with this piece here. So that would be 8 minus negative 1 is 9, right? So we're going to put that in. So it's 8 minus negative 1 equals 9, right? And then again over here, it works the same exact way, right? So again, and I put this model over here to show that if we had 5 minus 3 will tell us what this piece is. So 7 minus x, because x is in the same spot as the 3, so 7 minus x is negative 11. So that's what we need to put in for here. I do want to caution you because a common error that, well, it's not necessarily an error, it's more of a formatting situation, is that we have to put these in the same order as like what these are going in, right? So it's 5 minus 3. We literally have to do exactly in this problem, where is the 3? And so that's got to be the x, because the 3 is on this right side of our bar model, so we have to use the x because it's on the right side. Okay, and then lastly, now we're going backwards, right? So we know that, and I guess I should put these numbers back in. They're doing the opposite. So what if we then knew we have the 2, but we need to figure out what this piece is? Well, we would do 5 minus the 2, and we'll know that it's 3, this piece here. So on this problem, that looks like taking your 8, subtracting 9. So 8 minus 9 equals negative 1, right? And so that checks out. What I was saying before is basically if you reversed these problems, like if you put 8 minus 9 is negative 1 up here, and then you put this problem down here, it's going to say it's wrong, even though you do have the right problems, okay? So you have to put them in this exact order. Over here, we're going to just flip it, right? So again, 5 minus 2 is 3. So 7 minus negative 11 has to equal x. And there we go. We got those problems right as well. So all of addition problems and subtraction problems, when you're using the same numbers, they're all related to each other. So let's take a look at this second slide. All right. So now we're looking at subtracting with number lines. Okay. So it says, here's an unfinished number line diagram that represents a sum of 8. So I know that the word sum means the answer to addition, right? So automatically I know it's something that equals 8. That's what sum of 8 means, okay? I also know, so let's see, let's take a look at what they're doing here. It says, how long should the other arrow be? Well, if it's the sum is 8, that means our target answer is 8 right here, right? So the question is, how long should the other arrow be? Well, let's see. It has to go from here to here. So I know that that is a total of 1, 2, 3, 4, 5. So we know that that is 5, right? And this one we know is 3 because it starts at 0 and ends at 3. So this is showing 3 plus 5 is 8. So I'll go ahead and type in my answer. We know it has to be 5, which is good. Now, I did write an equation, but let's see what they say here. For an equation that goes with this diagram, Mai writes 3 plus x is 8. Tyler writes 8 minus 3 is x. Do you agree with either of them? And you can't agree with one, both, or neither, but you do have to explain. So go ahead and pause and write your answer in for that. Okay, so there's lots of things here that we could think about. In our past Desmos lessons that we've done, anytime they've asked us to write an equation, they didn't just say write an equation, they said write an addition equation, right? So that's what we've been practicing. And I already wrote an equation to show what was going on, but notice here I'll kind of do, they're using x in place of the 5, right? Because really, whoops, that's not, really that's what, we don't know the number, oops, based on the situation, right? So Mai wrote 3 plus x is 8. Well, that's what I wrote, right? Tyler wrote 8 minus 3 equals x. And here's where I'm going to go back to our last slides to kind of show here. I actually think I know addition can be related to subtraction. And so I also know that if I was actually solving for this problem, to do this, we have to do this, right? 8 minus 3 will give us that 5, that x, right? So I actually think these both can show um, what's happening. So if it was me, I would be clicking both. And I know the reason why I know that is because this shows the addition equation, but this is showing a subtraction equation. I also know based on what we had just done that I could also write it as 8 minus x equals 3, right? Or this one could be x plus 3 is 8. So these are all equations that show what's happening, right? And what's the unknown number? I want you to pause and write in what you think that should be. So I added in my explanation for what we just did here. And now I just went ahead and typed in that we knew that it was 5, right? Just from the beginning, we knew that we went up 5 from 3 to get to 8. And I knew this because of Tyler's problem, right? 8 minus 3 is 5. So that's how we knew what to do. Here we have another situation, and this is just like the one before. So what I want you to do is to go ahead and pause and try these out. Okay, so now this is saying what addition equation would my write if she used the same reasoning as before? And this diagram looks the same to me, except our arrow is different, but we're still trying to find a sum of 8. And so again, so this is going to be my target. So now I know my arrow is still going to start at -3 and it's going to extend all the way to 8. And this question's asking me to do what she would have written and what Tyler would have written. So I'm actually going to go back and look. So my's equation here was 3 plus x is 8. Okay. Interesting. So I know for this case, the first number isn't 3. So I know that this number started at -3, and then we added this. We don't know what this is. So that's x, right? And we ended at 8. So we know -3 plus x is 8. So I think that's what my did because she used addition. So if we type that in, let's see what happens. Whoops, -3 plus 8, whoops, plus x equals 8. And good, we got that right. This is what the same thing, but what would subtraction problem would Tyler write? So he instead did the subtraction problem to solve for the answer here. So he started with the 8 and subtracted the number that we knew, right? So he knew that we subtract out this -3, and that is going to give us the answer of x, okay? And then finally, they're asking us to find the solution, right? How long would the other arrow be? So we know it is, if we can count the jumps. I like to personally, if I'm in the negative and I end up in a positive, I like to count like, well, how many negatives were there? I know that this is 3, and I know that this length goes from 0 to 8, so I know it's 8. So I know the arrow is 11, positive 11. So what number would complete the equation? Well, it's positive 11. And I know that because you need to add positive 11 onto -3 to end up at 8. And that's how I know my answer. Okay, let's try the next one. So this again is exactly like the other ones that we've done. The only difference is now they're saying that this diagram shows a sum of -8. So we're trying to get here. So I want you to pause and try these out. All right. So I have done a couple of things here to kind of show what's happening, right? So I know that Maya is writing this as addition. So I know that she would be writing the 3 plus the x is equal to -8. So that's what that looks like for addition. And then I also know that Tyler rewrites this as subtraction. So we were given a 3 and we were given the -8. So what that means is he would write that -8, if you take away the 3, you're left with the x. And that again shows up as correct. Now this question's asking, how long would the other arrow be? Well, I know that we can kind of do the same thing. We could count how long this arrow is. I tend to do it more mathematically like this, where I know that from here to here is 3. And I know from here, from 0 to -8, that's a total of 8. Now, this one is interesting because the arrow's going backwards, right? So that's telling me that this isn't just 11, it's actually -11. So we need to type in that's -11. So the direction of the arrow shows me um, whether it's positive or negative, and then the number tells me how long it is, which actually, I take that back. The arrow's still 11, right? The number, the answer is -11 because that's where we add in the direction. So the arrow's still 11 long, but since it's going backwards, it's -11. And that's where I would type that into my explanation. All right, so let's try out the next one. So now we have to do the whole thing by ourselves. Draw a number line diagram for -8 minus -3. What's the unknown number and how do you know? Okay, so take a minute to try that out. All right, so I've started this off for this problem. And one thing that I did is I started by putting some numbers onto this number line. I started by counting, and I knew that there were 11 total numbers or slashes. So I also kind of had to look at this and decide, am I going to have to go behind -8 or not? So when I did this, I realized that if I make this -8, I have enough to make each one of these go up or up by 1, right? So -8, -7, -6, -5, -4, -3, and so on. I didn't number each one just because it's kind of hard to fit those numbers in there. So the first thing I did to draw my number line is I started with what it starts with, -8, right? So I went from 0 to -8. Now, this is telling us to take away -3. So this is also where I have to kind of think about what's happening. If this was sandbags, that means I'm starting at my -8, right? We add 8 sandbags. But then if we take off sandbags, I have to think, oh, well, if I'm getting rid of weight on my air balloon, it's actually going to go up. It's going to go towards these positive numbers. So to take away 3 negatives, I'm actually going to start at the -8 and take off 3. 1, 2, 3. And I would end up with 5 sandbags, right? So -5. All right. So what's the unknown number? The unknown number is -5. And then I'm going to explain that. So let's go ahead and take some time to do that. So my explanation was simply what we had just talked about. I know that I would end up at -5 because we're getting rid of or taking off negative numbers. Now, having said that, if we go back, we know that subtraction problems can also be written as addition problems, right? And if I were to look at this diagram from before, we know that the first number is what we started with, right? So we started at +3. And then we also know that if we're adding, well, that this number would be -11, right? Um, so let's go over here and I actually want to look at this problem. So -8 minus -3, we know it equals now -5. But we also know that this problem is the same thing as starting with -8, right? We still started with that, but it's the same as adding. Well, this number line is 3 long, right? It goes 1, 2, 3. And I also know it's a positive number, or it can represent a positive number because it's going in this direction. So we actually know that -8 minus -3 is equal to -5, which is the same thing as taking -8 and adding a +3. We still get -5. So I actually can use addition to solve subtraction. Let's look at this. So now we're going to be, it says we can add instead. So what we're going to do is we're going to go ahead and match up problems with number lines. Okay, so I want you to take a second to go ahead and try to connect connect up what goes with what. Okay, so I've kind of rearranged our cards a little bit here, and I want to take a look at this. I'm going to start with 3 plus -7. So I'm choosing this one because the first thing is we kind of know on all of our number lines with addition, the bottom number or the bottom arrow is typically the starting number. And notice it's starting at 3. So it starts at 3. And if we add -7, we know that that means it would have to go back this way because the negatives go towards the negatives. So I know that this shows 3 plus -7. So I'm going to add that on and hopefully we're right. Okay. And likewise on this one, it's showing that we're starting with +3. And to that, we're adding on +7. So this arrow is a length of 7 and it's going towards the positives. So I know that those match up. Now, let's take a look at these. It's hard to model subtracting on a number line, right? Um, the way that they're showing this is they have one arrow is going towards the negatives, right? One arrow is going towards the positives, and they have a dot on the 3, which is the starting point for both. So the way I matched these up is that I saw this was going backwards, like -7. So I went ahead and matched that with the one that was subtracting -7. Likewise, this one is showing that we're subtracting a +7, and this is showing a +7 on the number line. Okay? So here's what we're going to look at. Which expressions here actually have the same value? Which ones add up to the same thing or subtract to the same thing? So I want you to go ahead and try that out. For this one, I'm actually going to go back to my number line or to my card sort. And what I'd like to do here is take a look at, for instance, I'm going to write the answer, right? So 3 plus -7. Well, if I look at my number line here, I know that this is going to end up to be -4. And over here for my addition, I know that that's a +10, right? 3 plus 7. So let's kind of think these through and we're going to match them up with which ones are actually the same. So if I have 3 positives. That's like having 3 puffs of air in my hot air balloon, right? And then I take away 7 negatives or 7 sandbags. If I'm getting rid of sandbags, I know that my balloon is going to go up because we're getting rid of weight, right? So that would be 3, and then getting rid of those sandbags, that means it's going to go up 7 more and end up at positive 10. So I know 3 plus 7 and 3 minus negative 7 are the same. So let's take a look at this. For this one, it's saying we're starting with our 3 puffs of air, but now we're going to take away 7 puffs of air. So if I'm getting rid of puffs of air, my hot air balloon is going to go down and it's going to end up at -4. So these two match up with the same answer, and these two match up with the same answer. So we just need to add that into our work here. So you can go ahead and make sure you've got that. All right, so I went ahead and wrote in what we discovered from the previous slide. And then it's asking me, what do you notice? So I'm actually going to go back over to this slide to kind of explain that. I noticed that if I'm subtracting, so 3 minus positive 7, it ends up giving me the same thing as adding the opposite of the previous number, right? So 3 minus 7 is actually the same thing as adding -7, right? Which is why we've come up with the answer of -4. This works over here. Let me switch these. So subtracting -7 is the same as adding +7. So I noticed that subtracting a number is the same as adding its opposite. And when we say opposite, remember what we're talking about is 7. The opposite of 7 is -7. The opposite of 4 is -4. The opposite of -20 is +20. So when we're talking about opposites, we're really just talking about the same number with a different sign. Okay, so now here we're going to try this out, right? We have a table with a bunch of different types of problems, and let's try them out, okay? I want you to go ahead and pause and see if you can try a few of these. So I know that 8 plus -8, again, if you add opposites, this is from a different lesson that we had done. If we add opposite numbers, they actually cancel each other out and their value is 0, which is the same thing as, 8 minus 8. We already know that that's 0. And let's see if this holds up to what we did before. 8 minus 8, well, subtracting 8 is the same as adding the opposite of positive 8, which is -8. So 8 plus -8 and 8 minus 8, they're actually the same thing. For this one, 8 plus -5. Well, I know that these 5 negatives cancel 5 positives, so I'm left with 3. And 8 minus 5, well, that's also 3. Because if I subtract 5, it's actually the same thing as adding its opposite, adding -5. Here, 8 plus -12. Again, I know that if I have 12 negatives and 8 positives, these 8 positives will cancel 8 of the negatives, which leaves me with -4. Here, 8 minus 12. Well, I know subtracting is the same as adding the opposite. So 8 plus the opposite of 12 is -12. So 8 plus -12. That's what we just did there, -4. -5 plus 5, those are opposites. They ended up canceling each other out. Subtracting -5 is the same thing as adding +5. So -5 minus -5, 0. -5 plus 9, Well, 5 of these negatives will cancel 5 of the positives. So we're left with a positive 4, which is the same as -5 minus -9, because subtracting is the same as adding +9. So -5 plus +9, well, we already know is 4. And lastly, -5 plus 2, we're going to end up with a -3. And -5 minus -2, well, it's the same thing as adding +2. So -5 plus 2 is -3. Okay, so look back at the table. What do you notice? What's the relationship that you see between addition and subtraction? Okay, we know the relationship is that subtracting is the same as adding the opposite. Okay, and that concludes with a ready. Are you ready for more? I want you to try this out and see what you can come up with here. Okay. So I've started making some notes for myself here, and I'm kind of familiarizing myself with the table. Um, in this, I know that it says in the system 1 plus 2 is 3. So I showed that 1 plus 2 is 3. And 2 plus 3 is 1. So the question here, or how can you see that in the table? And so I've kind of shown that, right? This is just like a multiplication chart or a sums chart. So now, what do you think 3 plus 1 should be? So I know that 3 and 1, right, should be the same as 1 plus 3. So I can find that on my chart. So 1 plus 3 is 0. So we know that from the chart. So I think that should be 0. What about 3 plus 3? So let's take a look for our chart here. I'm also going to go ahead and take the time. I'm going to try to fill in things that I know here based on the commutative property. And the commutative property is something that we have been working on even in the previous parts of this lesson, even if you didn't know it. So the commutative property says that if 1 plus 3 is 0, then 3 plus 1 is also 0. So that tells me that in this chart, right, 1 plus 3 is 0, so 3 plus 1 is 0. So I'll fill that in, right? Likewise, if 0 plus 3 is 3, then 3 plus 0 is 3. So I can do that here. 3 plus 0 is 3. And then we can do the same thing. So 2 plus 3 is 1. So therefore 3 plus 2 is 1. Now, this is the only one that we don't actually have filled out based on the commutative property, because we never came to a spot where we did 3 plus 3, right? Now, if I'm looking at the chart, this is where we can start figuring out what is 3 plus 3. Okay, so what I'm going to do is I'm going to use something, it's called the associative property. And what the associative property means is that if I have numbers that I'm adding up, for instance, 3, and we're going to 3 plus 1 plus 4, the associative property says that 3 plus 1 plus 4 is going to be equal to 3 plus 1 first, whoops, plus 4, right? So we can kind of switch all these around with addition, right? So I'm going to use that for 3 plus 3. Here's how I'm going to do this. I know that, okay, for this number system, 3 plus 3. So 3 is the same as to get the answer 3, I can do 2 plus 1, right? Or 1 plus 2 gives me the answer 3, right? 1 plus 2, I'm getting the answer 3. So I know I could substitute in 2 plus 1 and for this 3, and then 2 plus 1 or 1 plus 2, however you want to look at it, for this 3, right? And we're adding all those together. So I know that the sum of all these numbers together is going to give me the same thing as 3 plus 3, all right? Now, on my chart, it doesn't help me necessarily because I know 2 plus 1 is 3 and 1 plus 2 is 3. However, I can change the order of these numbers, right? So this, and just to make some room for myself here, I'm going to erase the 3 plus 3. The associative property tells me that this answer is going to be the same as, well, I can just rearrange these numbers, right? The commutative and associative property tells me that 2 plus 1 plus 2 plus 1 is the same as 1 plus 1 plus 2 plus 2, or 2 plus 2 plus 1 plus 1, right? It doesn't matter. So if I can figure out what that is using this chart, I should come up with the answer of 3 plus 3. So here's how I did that. So 1 plus 1 is 2. So I know that's 2, right? And 2 plus 2, let's see, 2 plus 2 is 0. So that's 0. So I know the answer is also 2, right? Because 2 plus 0 is 2. So I know that 3 plus 3 is 2, okay? Now, what should 3 minus 1 be? Okay. This is where I'm going to use a tape diagram here, or bar model. So I know 3 minus 1 would look something like 3. They're saying, what do you add together to get 3? And what if you're adding something to 1 to get 3? What is that going to be? So from here, I know to solve that, I would do 3 minus 1 is this, right? So I'm looking, what's the number I'm adding to 1? So I'm adding to 1 to get 3. So I come over here. I notice here it's, well, here's the answer 3, right? So 1 plus 2 gives me 3. Okay. So then what about 2 minus 3 is what? Okay. Again, that would look like, if I was doing a tape diagram, that's going to look like something like this. 2. So what am I adding to 3 to get to 2? All right. What do I add to 3? Whoops, and we know that is that. What do I add to 3 to get to 2? Well, 3. Right? Can you think of uses for this number system? And that I'm going to leave you to try to think about. So hopefully you liked this activity.